So 1.4. Describe how the principles of acoustic impedance and reflection and refraction are applied to ultrasound. So this is basically gathering up all the previous slides up until 1.4, where we looked at speed of sound waves in different materials, we looked at acoustic impedance, and we looked at different values of acoustic impedance. So the first step is a short burst of ultrasound is produced by the piezoelectric transducer. We know how that works from our previous video. So this pulse will travel through a medium until it reaches the boundary with another medium. It then, in step 2, some of the pulse will be reflected and will return to the transducer, and the computer then analyzes what the material was. So that the distance from the transducer to the boundary can be found by the recording time between the pulse and its echo. So that's what the computer will diagnose in its findings of its distance. Then in 3, some of the pulse will cross a boundary into a second medium. The refracted pulse will continue to into the second material until it reaches another boundary, where then it will be reflected again to return to the transducer, and some of it will be refracted for a second time. In this series of echoes, having different time lags from the initial burst will be recorded. Each represents a boundary at a different distance from the transducer, so you can picture this as a cross-section of the wave going through different materials. The amount of ultrasound reflected compared to the amount refracted at the boundary will depend on the different acoustic impedances of each medium, which we just learned in 1.3. A large difference in impedance means that there is more reflection and less refraction at the boundary, and you might want to underline that down for your notes. Okay, so basically waves will be reflected from a boundary to the transducer, or will be refracted until it continues on being refracted throughout that testing. Okay, so think about the distance between the pulse being set to the pulse being recorded back to its original position or original displacement.